Alright, in this video, we'll have a look at what Bayes' theorem is and in detail uh, try to dive into what Bayesian thinking can be in our everyday lives. The goal of this video is not to get too much into the mathematics of Bayes' theorem, but to actually explore how practical Bayes' theorem actually is. In fact, the way this rule is introduced to us in high school would probably be something like what people generally remember about this is there's probability of A given B on the left hand side, and then there's probability of B given A in the right hand side of Bayes theorem, and it is just plug and play, and what the formula generally uh, tells you when you look at it first is just it's just a way of getting from one way to another, like a probability of A by B and then probability of B by A, whichever you have, you just plug and play and you just get the answer. But that is boring, and Bayes theorem does way more than that, and we'll have a look at that. Probability is life saving. This is very relevant in the current times, the pandemic scenario, wherein everybody is trying to actually figure out I mean, given that they are tested, if they are tested COVID positive, and the accuracy of the test is let's say 99%, what is the probability that they actually are COVID positive, given that there is an evidence of being tested positive? That is, if you are tested positive, what is the actual probability of you actually being COVID positive? So those are some interesting questions, and the answers to those questions can indeed be life saving. I mean, depending on how what the probability is, what the odds are, what the posterior odds are, you'd like to figure out whether it's worth having a second opinion or another test that can actually improve or give you better odds of figuring out whether you're actually COVID positive. So this is why you may want to learn about Bayes rule. If you're a professional who uses statistics, this is a scientist or a doctor, a machine learning engineer or a computer programmer, and C, a human being. So this is what the textbook definition of Bayes theorem is, and what textbooks will tell you. And it's basically the law of probability governing the strength of evidence. Like, it tells you whether you can trust the evidence or not. uh, it's a rule saying how much to revise our probabilities, or change our minds, how much to change our mind when we learn a new fact, or when we get a new evidence. It's basically a law of probability that is telling you whether to believe. It governs the strength of the evidence, whether uh, in the case of COVID positive, it's basically if we are COVID positive, given that there is an evidence, that is, given that the test is telling that you are COVID positive, how much can we believe that test? And this statement would be much more clear. I mean, it'll be clearer in the upcoming slides. Okay, so basically, in a nutshell, this is what Bayes theorem is. Prior odds into relative likelihoods, so is going to give you posterior odds. So, given that you already have some prior odds, and you'd like to know what the posterior odds are after you got the new evidence, basically. And what is important about this is, in the case of let's this can be written again like this: probability of a hypothesis being true, given that the evidence is true. In this case, the hypothesis was you being tested COVID positive. Given that the test results have arrived and it's saying you are positive, given that the evidence is true, is basically the prior probability, that is the probability of the hypothesis being true, into probability of the evidence being true, given that the hypothesis is true, divided by the probability of the evidence being true. And this is the likelihood, and this is basically the likelihood of the evidence, E, being true if the hypothesis is true. So essentially, what Bayes theorem should give you is that evidence should not determine beliefs but merely update them. That is, just because like someone's telling you, or the test is telling you that you are COVID positive, uh, you are it doesn't actually mean you are COVID positive. Like, it merely gives you like a probability, and it basically gives you an update. Of course, like the odds of you being COVID positive would increase like after this test, because there is an evidence suggesting in that direction, but it actually does not determine belief directly straight away. So prior odds into relative likelihoods equal to posterior odds, and the denominator is basically the probability that the evidence is true. And in general, in most of the cases, this denominator is actually expanded into the sum of two probabilities, something like this. Like basically, that the probability of the evidence being true is basically, that can happen in two ways, right? One in which the evidence is actually true, given that the hypothesis is true, and the second case, the evidence can be true also when the hypothesis is false. So in this case, basically, the test results can be positive when you actually have when you are COVID positive, and the test result can also be positive when you do not have COVID, when you aren't carrying the disease as well. So this is basically the denominator of the evidence being true is basically the sum where the probability that the hypothesis is true multiplied by probability of evidence being true given that the hypothesis is true, plus the probability of the hypothesis being false into probability of evidence being true given that the hypothesis is false. So we have to include both the cases, and that's how we calculate the denominator. And this is the prior probability, like of you actually being COVID positive. Like the this is tricky, and there are several factors that can influence this part, the prior probability, and so depending on what this gives you now, this is the posterior probability. You can actually uh, decide whether to actually uh, trust this result or not. And what you can do to actually be much to be surer is actually get a second hearing or get another test uh, that completely where the test one test does not actually control the results of other tests in another way, that is, they're performed under different conditions. If you can do that, then basically you can use the result of test 1 as your prior probability of test 2 when you're calculating the same thing, the same equation for the second test result. You can basically use this, the prior probability, as the posterior probability of test result 1. And this way you let's say in the first test I get like something like I'm only 10% sure that the test result is actually correct, and in the second case I get like, after substituting I can substitute the 10% here, that because that is my prior probability of me actually being positive. I can use that to actually determine what the posterior probability of my test result 2 is. So this is Bayes theorem is actually very useful in everyday life and in diagnosis as well. So that is literally life saving, and the this is actually really interesting. And this is how Bayes theorem applies in our everyday lives. What it tells you is, because evidence should not determine belief but merely update them. Uh, what this actually means is we shouldn't be too quick to judge. Just because you see something, let's say there was a driver who just who's very close to crashing a car or something like that. He must be a bad driver, right? I mean, like, that'll be a conclusion, a immediate conclusion. But what Bayes theorem tells you about that is that, like, it's incorrect to actually conclude that way, to believe that way. Just the evidence presented to you right now does not determine the belief that the driver is bad and the driver is uh, a terrible driver and so and so. Like, it basically can be due to several factors. Like, I mean, what if there was someone like serious, someone close to him was serious and he had to rush to the hospital, and that's why he had to drive so fast. There can be several factors as well. So basically, you have the right to basically update your belief depending on the evidence you're getting right now, but that does not, like, really allow you to just determine the belief straight away. So, and the second one, second random fact, knowledge, from base rule, is that, like, you have to remember our priors always, and we have to protect our priors. Like, we have to pay close attention to the details, because every small evidence actually does, like, affect, what our belief, what our hypothesis is, the probability of our hypothesis being true is. Like, every small detail matters here, and the truth isn't binary. Like, again, it's, you can never be certain. It's, after all, a probability, and good predictions, they do require good priors, and hence, like, it's very important to protect priors. That is, like, counterintuitively, this may mean you shouldn't consume news, like, because of misinformation and other factors. Um yeah, so it's important to remember and protect our priors. And the next one is to challenge your bias and your thinking. Like, what is right? What is wrong? Like, what if you're wrong? I mean, what if you're right? Like, on what basis, like, do you actually form the notion of what is right and what is wrong? So basically, we have to continuously challenge our biases and thinking, and we actually have to update them incrementally as and when we get new evidence. And what I'm trying to tell here from this is that, there's a very infamous marshmallow test, like, where they actually do this on young children, wherein, they are asked to actually, resist a single marshmallow, so that, like, they, if they do resist, and they do actually, they're rewarded, like, after like 15-20 minutes with another marshmallow. So and whoever actually, like, is able to succeed in this test, it seems that, they are actually successful in their everyday lives, like, because they're able to actually resist instant gratification. So this is one study. Like, what I'm trying to get here is that, we can actually challenge this as well. Like, what if the children actually, like, who are succumbing to temptations, and they're actually, consuming the marshmallow right away, what if, like, they are actually from an environment where they don't trust elders, like, where they aren't actually, used to elders, actually behaving the way they promise. Like, what if the moment the guest actually left the hall, uh, because of the children's bias, like what if they did not trust the elder to even come back into the hall, and that's why, like, since like they aren't coming back anyways, like, so your best bet is to consume the marshmallow, right? Like, so yeah, everything isn't binary, and uh, several times we have to challenge our biases and thinking as well. So that was one quick example. uh, A Bayesian way to view atomic habits. This is a very famous book by James Clear, and these are like stuff I just picked from the second chapter, and I'm just trying to relate Bayes theorem to that. And James Clear says your behaviors are usually a reflection of your identity. What you do is an indication of the type of person you believe you are, either consciously or non-consciously. So anyone can convince themselves to visit the gym or eat healthy once or twice. But like for long term, results, like one needs to actually present themselves with new evidence every day, like, and only then you can actually believe that you are a gym going person, or you are someone who exercises every day. So basically the goal is not to run a marathon, but the goal is to become a runner in your mind. And to do that, to actually emphasize such a hypothesis in your mind, uh, it's important for you to present yourselves with everyday evidences that you are actually like capable of doing it, and you have to exercise every day. That's why habits are important. And for a long term effect, for you to actually succeed in the long term, you have to present yourself with evidence every day. And this is of course a double edged sword as well, because I can use the same thing in, I mean, the other way around. Like, let's say, I actually think that I'm not a morning person. So that is my hypothesis, and this can work against me. I mean, every day if I like wake up late, or if I'm running late, and that means I'm presenting myself with an evidence that I'm not a morning person, and this is just self-feeding prophecy, wherein like this is a double-edged sword, of course. Every day the hypothesis of me not being a morning person is being validated with my evidence I'm presenting every day, and that applies to you being bad at math as well, because you're not practicing enough, or you're just getting bad scores repeatedly, and it just feeds into the loop. So this can be used both in a positive direction as well as a negative direction, depending on the way you actually want to. So you are of course in control of your destiny. And yeah, this is a fun exercise. Like, we can try reframing or rewording lots of self help advices into a Bayesian mode of thinking. And of course, the disclaimer is to not overfit everything you see into a Bayes rule. And that was it. Thank you for watching.